Hello, hi everyone. So welcome back to our channel. Now we are moving to the test series number 3. That is a KCL and KVL chapter 3. Okay, this test series related to the KVS TGT work experience teacher. Total we have 20 questions. Let us start the question number 1. According to KCL as applied to junction in a network of a conductors. So here, total sum of the current meeting at a junction, no current can leave the junction without some current entering it. Net current flows at the junction is positive. Algebraic sum of the currents meeting at the junction is 0. According to the KCL statement, algebraic sum of the current meeting at a junction is equal to 0. Otherwise, algebraic sum of the entering currents is equal to algebraic sum of the leaving currents. Which option is correct? Option D is the correct option. So, second question. Kirchhoff voltage law is connected with. Kirchhoff voltage law is a sum of battery EMFs plus IR drops. That's yes or no, sum of IR drops, sum of EMFs. So this is a KVL. So here IR drops, yes, it is there, and battery EMFs. So junction voltage, not junction voltages. So option D is the correct option. A and B. So D is the correct option. So here option D is the correct option. Right. Next we are moving to the question number 3. According to KVL, algebraic sum of all IR drops and EMF in a closed loop of a network is always 0. So I don't give that much explanation for this theory question, because these all are statements only. This particular KVL, this particular question answer is also statement. That's what I'm explaining directly. So next we are moving to the question number 4. All of you following? According to the commonly used sign convention of voltages, this also from the theory class in our app we discussed in detail explanation. So according to that, rise in voltage is considered as a positive. So option B. What is mean by rise in voltage? C. So here this is a voltage source, negative and positive. For example, here apply, this is a sign convention, clockwise direction. So whenever arrow from negative to positive, that means raising potential here considered as a positive magnitude. That's what here, raising potential considered as a positive magnitude. That is one of the common convention. Next one, the algebraic sign of IR drop is primarily depending upon. What is mean by IR drops here? For example, this is a circuit we have. Right. What is the current direction? This is the current direction. What is IR drop? Plus and minus I into R. For example, instead of current connected here, I will connect like that, plus and minus. What is the current direction? Here. That means this IR drop is depending upon the direction of current or not. Just here, direction of current flowing through it. That means sign convention of IR drops is based on what? Direction of current. All of you following? Right. Next, question number 6. While applying the Kirchhoff's law to electronic circuit, assumed direction of current flow must be clockwise direction or left to right. So that means option D is the correct option. Okay. Next we are moving to the question number 7. So in the question number 7, in the circuit shown in the figure, V1 and I1 will be. You want to find out V1 and I1 also. So it is easy to find out V1 and I1. This is the 5 volt, right? Parallelly connected. Whenever parallel, property of parallel circuit, voltage is a constant. That voltage V1 is equal to 5 volt. So one of the voltage value is known. Next, I1. Once this is a 5 volt, What about the current I1 is equal to V by R? What is the V? 5. What is the Ri? That is equal to 5 amperes. 5 volt comma 5 amperes. Look at the options. 5 volt comma 5 amperes. That is which is the option is correct? Option C is the correct option. Okay. Next, we are moving to the question number 8. In the question number 8, in the shown in the figure, I. Find out the I in the circuit. It is easy to find out. Just look at here. This is the 4 ohms. This is the 4 ohms parallel with 10 amperes that convert into current source. So in our app, we left with the current source explanation from the network theorems. So I will explain that network theorem, current sources also. Just time being, I will explain here current sources. How to convert this current source into voltage source. That's why it is here. V is equal to conversion. V is equal to IR. What is I10? R is equal to 4. That will be equivalent to 40 volt. Okay. So here the voltage source, the current source equivalent to voltage source is 40 volt. Just look at here, 40 volt. What about resistance? 4 ohm, that is connected in series. Clear up to? So this is a conversion of voltage source to current source conversion. Coming here, voltage source to current source. Next here, arrow direction is upward. That's why plus is upward, minus is downwards. Next, already 20 ohms is there. Next, here 8 ohms connected in series, like this convention, and then this arrow is downward, right? So downward is positive. Next, how to find out the current voltage? V is equal to IR. 5 into R is 80, that is equal to 40 volt. That means it is a 40 volt. Okay. Finally, this is a circuit, simplified circuit. The current will be now I. So finally, I is equal to V by R. What is a V? 40 plus, this is a plus, this is a negative. Plus and negative connected in series, adding. So 40 plus 40 by total resistance 4 plus 28, 38, 32, 32 plus 8, 40. That means 80 divided by 40, that will be equivalent to 2 amperes. Just look at here, this is a 2 ampere. Okay, option B is the correct option. Next, we are moving to the question number 9. The value of current I flowing in 1 ohm resistor, yes, in the circuit shown in the figure will be. So, whenever voltage and current source are connected in parallel, there is no effect of current source, only voltage source is effective. So, the current I is equal to V by R. Here, parallelly voltage is the same, resistance is 1 ohm, that's why it is a 5 amperes. What is the option? Option C is the correct option. Next, we are moving to the question number 10. In the circuit shown in the figure, I1 is 1.5 amperes, I2 will be. It is given I1 value. We need to find out the I2. So, it is a simple, look at here. This is 6 volt. What is I1 value is given? 1.5 amperes. Whenever I1 is given 1.5 amperes, you can find out the voltage, right? This is the direction of voltage. So, voltage I is equal to V is equal to IR. What is I 1.5? What is R2? That will be equivalent to 3 volt. What is the voltage now here? 3 volt is a voltage across 2 ohm. This is a 6 minus 3. That means what is the voltage available here? The voltage available here is 3 volt. Okay. So whenever the voltage across this particular resistor is 3 volt, okay, then current I2 is equal to V by R. V is 3, R is equal to 2. That will be equivalent to 1.5 amperes. What they are asking, the current I2 will be 1.5 amperes. Okay, so how will you know? This is a procedure to find out. Whenever you practice more and more problems, then you can play with the circuits, right? So that's why practice more and more tests, then you will get the success in the examination. Option C is the correct option. So our app is one of the best app to provide the qualitative test series, quantitative and qualitative both. Number of questions I will provide, and then questions are very well structured, and it is examination point of view. Maybe exam paper going to be tough, you can, even though you can answer the questions. That's why I'm making the particular test series are difficult level, medium level, and easy level questions are there in the our test series. Okay, if you are interested, in the description we are providing the app link. Okay, then we are moving to the question number 11. In the question number 11, the current in given circuit with the dependent voltage source, they are asking to find out the current. So this is a V0, 3 ohms, right? So this is a V0, this is a 3 ohm. What about the current? I is equal to V0 divided by 3 amperes. So whenever total entire, this is a series circuit, right? So here also V0 divided by 3, here also V0 divided by 3. Whenever all the currents are same, we can apply the KVL now. We can apply the KVL. 24 volt, okay, supply voltage is equal to sum of the IR drops. That means 1 ohm into V0 by 3, right? Here negative to positive, that is also here drop. So minus 2 V0, next here plus V0. Is it okay? Next coming to here plus, because this sign plus minus, plus 4 into V0 by 3. Okay, just algebraic sum of the IR drops is equal to EMF. EMF is equal to algebraic sum of IR drops. So V0 by 3 is a common 1, here minus 6 plus 1, here plus 4. From that V0 here 6, here 3, LCM is 3. So here 7, 8 minus 6, 2 by 3 is equal to 24. From that V0 is equal to 24 into 3 by 2, that will be equal to 1 time 12 times, that is equal to V0 is equal to 36. Once you got V0, we can find out the current here, right? The current formula V0, that is a 24 by 3, right? Sorry, 36 by 3. That is equal to 12 amperes. What is the answer? Correct option 12 amperes. Option B is the correct option. Okay, this is the 12 amperes. Next one, question number 12. An electric circuit with 10 branches, 7 nodes will have 10 branches, 7 nodes will have how many loop equations? The formula for loop equations, branches is equal to 10, comma, number of nodes is equal to 7. So the formula for number of loop equations is equal to B minus N minus 1. So what is a B? 10 minus N minus 1, that will be equivalent to 4. So 4 equations. Option B is the correct option. Okay, next, for the circuit shown in the figure, what is the voltage across the current source IS? So you want to find out the voltage across the current source. So for that, it is easy to find out. First of all, find out the equivalent resistance. These two are connected in parallel. R equivalent, total R equivalent is equal to 1 plus, in series with these two, 3 into 6 by 3 plus 6, that will be equal to 1 plus 18 by 9, 2, that will be equivalent to 3 ohms. Total resistance of our circuit is, this is the current source, 2 amperes. Okay, this is a circuit. What is a 3 ohms? Once you know this is the current 2 amperes, what about the voltage now? Voltage is equal to IR, that is a 6 volt. It is a parallel circuit, right? Here also definitely same voltage appears. What is the voltage now? 6 volt. Option D is the correct option. Okay. Next we are moving to the question number 14. In the question number 14, if the voltage V across the 10 ohms is 10 volt, what is the E voltage source in shown in the figure? So it is given, it is a 10 volt. What is the voltage of this particular thing? So how to find out the current here? I is equal to V by R. 10 by 10, 1 ampere. This is a 5 amperes. What about the current now? This is a 5 amperes. This is a 1 ampere. That means here current will be 4 amperes definitely. Whenever current is 4 amperes, this is a positive, this is a negative. You can find out the E. That formula will be E plus 5 into 4, 20. Here negative to positive, positive to negative fall in voltage, that is a minus 10 is equal to 0. From that E is equal to minus 10 volt. What is the answer? E is equal to minus 10, and that is option B is the correct option. Next we are moving to the question number 15. In the question number 15, for the network shown in the figure, what is the voltage across the current I? So it is a just apply the K. This is the direction of current. That's why it is positive or negative. Apply the KVL. So it is a V plus I into R. This is a form voltage across. For example, it is a E. So it will be voltage across the current source. So E is equal to V plus IR. Option B is the correct option. Next we are moving to the question number 16. In the question number 16, in the shown in the figure, current I1. So it is a easy. It is a 5 amperes. 5 I1. It is a I1. Both are incoming and meeting here. That current, that value is equal to 6 I1. So you want I1 only. Just apply the KCL here. KVL here. The polarity is here 6, right? So we can apply plus 2 minus 250 positive minus, because positive and negative, minus 2.5 into I1 plus minus 60 I1 is equal to 0. So from that 62.5 I1 minus is equal to minus 250. So that will be equivalent to I1 is equal to 250 divided by 62.5. That will be equivalent to, just calculate that value, you will get the 4 amperes. What is the option? 4 amperes. Option A is the correct option. Next we are moving to the question number 17. In the question number 17, the number of independent KVL and KCL equation for the network with the N nodes, I links respectively, L links are respectively. So the formula, number of independent KVL equations. The first thing, that one only, KVL equations is equal to L, number of links only. So L, and second one, number of KCL, number of independent KCL equations is equal to N minus 1. So which option is correct? L comma N minus 1. So option C is the correct option. So KCL equations N minus 1. So here L comma N minus 1. So option B is the correct option. So B is the correct option. L comma N minus 1. Next, question number 18. The total number of branches in a network is equal to B. The graph of the, as N branches, the minimum number of line currents will be. The minimum number of line currents formula, minimum number of line currents is equal to B minus N. So the formula here B minus N, option C is the correct option. Next one. In a nodal analysis, the preferred reference node that is connected to first one ground, second one many parts of network. So option D is the correct option. Coming to the third point, the highest voltage source, not highest voltage source. If it is in the examination, it is given like that number of highest number of voltage sources. Highest number of voltage sources. In case of this particular option is given, 3 options are correct, 3 statements are correct, but here given highest voltage source, not highest number of voltage source. So I will explain here. Nodal analysis preferred whenever more number of voltage sources are present. That is a point here. Okay, coming to the last bit. Kirchhoff's current law is applicable to, yes, closed loop. Kirchhoff current law, it is not applicable, it is not for closed loop. It is a junction as well as junction network. We are applying the KCL, Kirchhoff current law. So option B is the correct option. Junction in a circuit, we are applying the KCL. So this is about I will explain here what is mean by junctions. For example, here different currents are entering or leaving. This particular point here, call it as a junction. Junction is a current meeting point. So then only you are applicable to KCL. Junction is present. That's why option B is the correct option. Okay, this is about the explanation about KCL and KVL test series. So those are enjoying the classes. If you are really interested, go and download our app. Today is the offer is available, coupon code. Really, if you are interested, you can purchase before 12 o'clock today. That is 31st of December. We are coupon code is valid till 12 o'clock only. Thank you.